So if you had those streams functioning really well, you wouldn't have these the huge boulders from the back of the watershed ending up in the bay. I'm pretty impressed. That's a lot of energy over a long distance, and there's not many breaks in that energy. So you look at it and say, okay, we'd like to modify that. Like, we'd like to meander that a little bit. We'd like to have these deep pools where the water rushes in and then it slows down and you've got turbulence and the water mixes and dissipates a lot of energy. And there's a lot of different ways to do that. Slope, width to depth, structure within the stream system, grade control structures where you can drop it safely into a pool. I mean, there's vegetation is a big one also. But most of those, you either need some space, or if you successfully slow this stream down a good bit, it's going to slow down and it's not going to move as much water through this, definitely not as much as you do on that concrete lined channel. So then you get into flooding problems. So you've got to look at it, and conceptually you got to say, okay, I'd really like to have that happen, because if we do that, then the fishes and the insects and everything within the riparian corridor and within the stream, that would function a lot better, would be healthier and have a better place to live. And then in this case, you'd have quite a bit of a reduction on the amount of pollutants and sediment and things of that nature, fresh water into the bay. So then you look at it and you say, okay, what can we do? You know, that's a big thing. And that's why Cindy and Debbie brought us in this week, just for us to listen and look and understand these systems and think things through and try to come up with some ideas, some different ideas, based on our experience with the fact that we've worked for years on a number of different systems, big, small, and in between. So you look at that and you say, wow, I got too much water, too much sediment, too much pollution, and I'd like to reduce all three of those to some degree. And one of the note cards that we got, Debbie and Cindy handed out note cards to the groups, and we had great participation, a lot of agency folks and everybody from different backgrounds to help us understand things and help the Corps of Engineers to understand so that we can go forward with our parts of these projects. And one of the note cards said that every drop of water is going to count. You know, because in a lot of cases you look at it and you say, oh man, we got room, we got space, we can divert water, we can slow water down, we can make water go into the earth and as groundwater and things of that nature. And if you've got space, you can do that in a lot of cases. And this one's going to be a little bit tougher, but that's kind of what you have to think about. Everything that you can slow down and you can get it to go into the ground as groundwater recharge is going to be a good thing. You're not, to a degree, you're not going to be able to miss anything. You're going to have to work hard on maybe a whole bunch of little things that are going to snowball into success. It is one of the things that I can see with these projects and with these watersheds. So we've thought about a bunch of different ideas. We're going to look at some more streams this week. We're going to have a brainstorm session all day Wednesday. We've got a report to the Colonel on Friday with some of our findings and some of our ideas and maybe ideas on how to go forward. So just, you know, there's a lot of little things and that there's different parts of the country that have taken some major steps toward this. One thing that I think, or we think would be pretty effective out here would be a type of rain garden, okay? And that's typically a small section of land. It's in urban areas typically, although we could use it on the fringes and on the edges of where the water comes down to steep parts of the mountains, where you basically construct a small basin and you dig it up and you dig out the middle of it and you put in an engineered soil in it. So it's almost like a French drain. You're going to mix in typically sands and mulch and gravels, and it's a catchment basin, but it's designed, when it catches the water, it's designed for that water to drain into the soil and go into groundwater in a relatively short period of time, like 48 hours, so that you don't have any mosquito problems or any breeding problems like that. And these things can be amazingly effective. They can take out almost 99% of pollutants. And Kansas City just did they've had a big push over the last couple of years where they were going to put 10,000 of these rain gardens right in residential and urban areas. And some of them it's kind of unique. You know, you've got a housing subdivision, and you've got sidewalks on both sides. You don't really need sidewalks on both sides of your street. They'll take out the sidewalks on one side, and then they'll put in those rain gardens. And typically they're a relatively small depression, but you can also plant them as a garden, or even as a native garden, or you could have it as a flower garden. You know, but the principles are similar to the rain garden, no matter how you're going to vegetate it. A lot of these have been done in parks and areas like that where they won't have any curbs, or they'll cut sections of curb out, and the water off the park. We took pictures yesterday during the rainstorm of oil and stuff going into the storm drains, going right into storm drains, going right down, going out into the stream. There it is. Once it's in a stream, you're in trouble. It's very, very hard to get it out. You've got to stop it before you get it there. So you know, some communities have adopted some rules where you can't put any curbs in. So everything that's going to be on the pavement is going to drain off of the pavement immediately, and then it's got to be handled. So it's got to go in these rain gardens. The other one is permeable pavement, which is kind of a new thing, but that's still well known. We talked to Diane over at the Marine Corps base, and she was pushing that, and she got shut down in it. But that's where it basically rains on the pavement, and it goes through the pavement, and it goes in. And this groundwater thing, besides the pollutants and everything, and not having a delivery to the bay, the other important part about that is a lot of these streams go dry during the dry season, and one of the problems is the fact that when it rains, everything runs off, everything goes into the stream, the impervious surfaces, everybody's roofs and parking lots and roads and driveways and sidewalks and everything else, and it goes down to the ocean. But you know, when you look back in history, that water should percolate down in as shallow groundwater. It should go into the earth. It shouldn't run off, or a large percentage of it should not run off. And then it'll get cleansed, it'll get cooled, and it should come out days, weeks, months, maybe years later. So you should have this percolation of this water coming down through underground and come into that stream to give you a base flow in that stream. It's kind of like it's like a million small springs coming into that stream on both sides. Okay, so that's what you want. You want year-round water. You want cool, cold water, non-polluted water. And if you can get these natural systems working again, you get all of that. Green roof deal. Has anybody on the islands, has anybody done any of that? where they've done the roof gardens and okay. You know, and I think that might even work a little bit better on a commercial side. But if you know, if you've got sponsors or people that are businesses that are green minded, you know, if they take a step forward and do some of these roof gardens, that would be really cool. Rich and I are walking through here, and we're looking at these stream systems and a lot of non-native trees and things of that nature. The backyards right up against the stream. You say, boy, you know, we'd like to have a riparian corridor, but it's hard to get it to grow in that concrete, number one. And it's vertical, straight up and down. It's tough to do anything with that. But, you know, what about folks' backyards? Can we do, and this would be great for y'all, can you do an outreach where somebody could study and figure out what plants would be needed kind of on top bank next to the stream, and could you do an outreach where those plants would be available and there'd be people to help plant or whatever, and you could you don't have a good riparian corridor, but can you make a riparian corridor in everybody's backyard and get people to accept and say, hey, would you mind having a couple trees in your backyard, or shrubs and native species? Maybe some of these could be low growing, but they could intercept some of the runoff. Okay, so you could almost have a swale or a riparian buffer in those backyards. Lots of different ideas. There's a bunch of stuff that probably don't have time to go into all of it, but there's a lot of different ways to, you know, slow that water down, stop that water, get it to and train in as groundwater and do good things. Do you want to talk a little bit about buffers and maybe some of the ones up in the hills?